We're going to be talking about using TypeScript with the ArcGIS API for JavaScript. My name is Rene Rubalcava. I work on the JavaScript API to Redlands. I'm joined by my good buddy over here, Stefan. He works out of our Zurich office, and this man here is much smarter than I am, so please ask him all the questions you've got. Let's go ahead and get started a little bit. And I always do this because I love doing it. How many people here are using TypeScript? That's way more hands than I saw last year. How many people here want to use TypeScript? All right. I mean, not all hands went up. I'm not sure why you're here. By the end, I'm hoping you'll all want to use TypeScript once you see what we got to say. So this is a bit of agenda. And we're not going to talk about all this stuff. We'll talk about some tooling and setup and stuff, working with the API. I'm going to go over a little bit of decorator stuff and accessors and all that, some advanced concepts. Stefan has a really cool demo to show at the end that I think you'll really be interested in. So super quick TypeScript intro. There was an intro TypeScript session, I think, today and today. It repeated twice today. So hopefully you attended that session to get some really intro stuff. But the basics of it is that TypeScript is a superset of JavaScript, and it transpiles to JavaScript, meaning that it doesn't, it's not a completely new language. You could essentially just take a JavaScript file, change the extension to .ts, and TypeScript will work. You know, and if it doesn't work, that means something's wrong with your code somewhere. You're doing something weird, right? You get advantages of some cool stuff like all the new JavaScript features like arrow functions, import, async await, spread operators, REST operators, all this really cool new JavaScript stuff that isn't quite supported in all the browsers yet. Everybody but IE, of course. You get types. Types are really cool. We'll talk a little bit about types and how they are very useful when you're building your applications. How many people here have worked with a typed language before, if not TypeScript? All right, cool. This is not Java typing, so please don't worry about that. We're not going to have 20-character function names and everything. And like I said, it's compatible with the existing JavaScript. You can pretty much almost just change a JavaScript file to a TypeScript file, and you get a lot of cool benefits. This is great for us and our team. So we have a very large code base in the JavaScript API. We have close to, I want to say 20, well, if you count all the PEs, project engineers, we've got about 24 people touching this code base on a regular basis. Couple dozen commits per day, multiple PRs per day. TypeScript really is useful for us working on a large team to make sure that everything kind of works cohesively. That functions are created properly, arguments are typed properly. It just makes it a really nice experience. Easy to refactor, especially using the right tooling. If I rename a module somewhere, it will rename that module everywhere in my code. If I change the type arguments for a function, it will validate that across all my code and tell me that something is not accepting the correct type anymore. It's a really great refactoring tool. Easier to test. I mean, I don't know. You don't test for like, is something a number anymore? And you probably shouldn't be testing for that to begin with anyway. So that's not really where the benefits come in. But you can kind of type your test on what you expect the outcomes to be. So that's kind of what we mean by saying it's easier to test, right? You can have all these nice interfaces that you should be expecting for stuff to happen. And the big benefit, of course, of all this kind of wraps everything up is it helps prevent technical debt. You're not going to be chasing down bugs that entered your code base maybe 3 or 4 months ago because you would have caught them early on. It kind of prevents you from cheating in a lot of ways too, for putting little hacks in your code just to get something to work. Not saying it prevents it, but it kind of helps you from doing that more often. So some of the fundamentals of TypeScript, right? So primitive types, type foo as a number. This is really a type alias. And now I can go ahead and I can reference foo as a number everywhere in my application. This is kind of like writing a DSL, right? You're starting to create these types that are going to reference primitive types that you're just going to use as your own types in your application. So it's kind of a cool way to do stuff. Type inference. Okay, so you don't have to type everything in TypeScript. Not really. You can let the compiler take care of everything for you. So if I say foo is equal to 8, then that foo is a number type everywhere from now on. These are kind of small, huh? There we go, a little bigger. Foo is going to be a number type everywhere. And I can't change foo to a string. I can't change foo to an object. Foo always has to be a number whenever I use it again. This is the type inference you get with the compiler automatically. Interfaces. So interfaces are really nice. Actually, let me go straight to my demos here. So I want to talk about the setup. So when we set up TypeScript, this is kind of how you're going to set up your TypeScript config. We provide this in our documentation on our SDK page. So you don't have to, don't take pictures, don't worry about it, it's on the documentation. Some of the keys here is the target will be ES5, right? So you're going to target, you want IE11 to work, and some other things. AMD, so this is just for other pieces of the application that would work. You're probably going to be using CDN or something like that, so you want AMD as the output from TypeScript. And then we just have a little file here. I'm going to import my map from Esri map, import map view from map view, and then again, this looks just, all this here looks just like regular JavaScript. I mean, there's nothing special going on here. Even these imports are JavaScript imports. This isn't a TypeScript only thing. You get that with something like Babel, but now you get these documentation here. So I know that my map takes properties of Esri map properties, and they're going to be certain things. We even have, so we updated our typings in the JavaScript API to actually point to the documentation for everything in VS Code, right? So that's a really useful tool. And let me also show, well, I'm going to get to some of these in a moment. So what direction am I going? Here we go. So types and interfaces are a little different. You can create a type. I use types all the time. They're kind of fun. And the thing with types, though, is you cannot extend a type, right? You can create an interface, and that interface can then be extended later on. I show that in the next slide. But basically, it's two different ways of doing things. A type is a type, like treat it like a primitive type, but an interface is more of a contract that you're writing that something needs to meet. So that could be for arguments, that could be for properties, not so much classes, don't worry about it for classes, but it's really for arguments and properties where you would use it most. Here's the interfaces, facilitate predictable behavior, right? So if I have a foobar interface and I have this Waldo object and I have a method that's going to return a foobar interface, then the TypeScript compiler needs to validate that I'm providing all the right properties that meet the foobar interface. So this is the contract that I am making with TypeScript. I'm promising TypeScript I'm going to do everything correctly, and it's all just going to work just fine, right? Classes. So classes are part of JavaScript. They were part of TypeScript before they were like fully finalized in JavaScript. And that's the thing, when things reach, I believe it's stage 2 in the JavaScript spec, that's typically when they go into TypeScript and you can start doing some cool things with them. So classes are available for us to use, and you don't need to declare something as public in TypeScript. If you just declare it, it's automatically going to be public. You can declare things as private. You can even declare things as protected. There's abstract classes in TypeScript. So abstract classes are not meant to be instantiated, they're meant to be extended. So that's one thing to keep in mind as well. If you decide to go down that route, you don't have to. I mean, all this really cool stuff is there. It's available, you can do it, but there's no rule that says you have to use it all, right? So again, I create a new Waldo, and if I try and use a private method on Waldo, there's that iterate number method, I can't. I'm not allowed to. The compiler won't let me. Now, in the real world, in JavaScript land, you could still access a private variable. There's no rule that says you can't. You try to hide things. And in JavaScript, there's methods that you can try and scope things out so they can't be accessed by the outside world. Don't worry about that with TypeScript normally, because the compiler will make sure you can't do that. Extensions. So this is what I was talking about, interface extension. So basically, if I create like a point interface, and it's going to have XY coordinates on there, maybe I want to extend that to support 3D. So I'm going to add the Z coordinate to my point interface. I can extend my point, add a Z type to it, and now I'm good to go, right? And I think oh, there we go, I got cut off a little bit. So I can extend my point, and then I can add a time to that, and You know, you can do all kinds of really cool stuff. But as long as I honor my 0.3D contract, I'm good to go. And this would be like, yeah, 40. So now we're talking about adding time, which, by the way, is coming to JavaScript API to the session tomorrow on time if you want to look that up. I'm just saying. So development tooling. So if you haven't noticed by now, I am, well, that's next slide. But I am using VS Code, and we'll talk about that in a moment. But we do provide our typings. If you didn't know that, we have typings for 4x and 3x. The default is we install typings for 4x. If you want the typings for 3x, just it's at type/ArcGIS API @3, and that'll get you the 3x typings as well. So this is what you do: install TypeScript, which by default you need Node and npm. So if you don't have that, then definitely get all that. And you'll be good to go, right? And if we look at the sample here, my setup, our package.json, my dependencies, I've got the JavaScript typings, I've got the Dojo typings in case I need them. I'm using tslint, and I don't really talk too much about tslint. You can set up tslint with some rules for how you want the code. Like you don't want to allow certain things in the code when people are writing it. Tslint's pretty useful for that. If you've ever used ESLint, it's the same idea. Oops. So like I said, a lot of the team these days is using Visual Studio Code. It works really great. I mean, it was kind of built from the ground up to work with TypeScript, and it's only gotten better since the initial release. There's a guy, I won't point him out, but there's a guy at the island that was using Notepad++ up until about 2.5, maybe 3 years ago. And we got him off of that, and he's using Visual Studio Code now. And I always bring it up because it's pretty funny, but Jan, for the longest time, used to edit his TypeScript in the Chrome developer tools before he moved to VS Code. And it worked. I mean, he was happy. It was fine. I mean, yeah, things were great. But you can, we like using Visual Studio Code. Like I have here, I still have a habit every now and then of going into Vim and doing stuff. And you can install tooling for Vim to capture any kind of TypeScript errors and stuff that you do. It's a lot of fun. I mean, some things I'm just faster in Vim with than others, especially if I have to do find replace, and I've got these cool keyboard shortcuts every now and then. But yeah, you don't have to use that. I still think that if you're new to everything, TypeScript is great. Another benefit for VS Code is that if you're not using TypeScript, let's just assume you don't want to use TypeScript. You go away from the session saying that you don't care. You can use VS Code, write your JavaScript, install our typings for the JavaScript API, and then compile your code with Babel or something. Writing ES6, you'll still get the typings help in the little drop-down. You'll still get all the stuff like I had here, if I come like app, this main TS, you'll still get this stuff in VS Code if you're writing regular JavaScript and not TypeScript, because you installed our typings. VS Code knows that those typings are available and what you're doing, and it just kind of magic kind of happens behind the scenes, right? I mean, it's cool. It's a really great IDE. I'm a big fan. The team on this has done a really remarkable job, and like I said, it gets better with every release. There's tons of extensions, tons of different stuff you can do. It's fun. So there's my VS Code commercial. You can let the guys know that that came out. So setting up, like I mentioned, we have a guide on the page. I kind of already showed that because I thought it made sense to show a little earlier than when I had my slides. You know, we're doing all this on the fly here, guys. So we have a good TypeScript setup guide to get you going. A lot of our apps on GitHub, demos that we show, they are in TypeScript. You're going to see us use TypeScript a lot. And people always ask us, do you recommend TypeScript? And we say, oh, it's up to you. But no, I'm telling you, TypeScript is great. You should use it. Go do that now. So working with JavaScript API, right? So the JavaScript API is still strictly AMD. And there's reasons for that, especially because we have a CDN. And that's because it's large API. I mean, how else are we going to dynamically load all these modules? If we give you the whole API at once, it's like 20 megabytes. Come on, guys, relax. You really don't need a 20 well, that's a lie. I think it's like 7, but 20 with all the extra stuff. Yeah, you don't need a lot of stuff. Classes are, so we export classes directly. This was an issue in a previous version of TypeScript where you'd have to do the equal require stuff, right? You don't need to do that anymore. You can just do this regular import map view from Esri's map view, because there's an option in TypeScript to have ES module interop, and it'll kind of make that defaults and everything kind of work behind the scenes, right? So it'll take care of all that for you. So you write your TypeScript like you would write ES6 imports to bring in our API modules, which is really nice. Autocasting. Okay. We've talked about autocasting a lot in the API. It's a really cool feature where you can don't have to new up like a symbol, new up a renderer, and do all that stuff. It's great. We love it. You're writing TypeScript. TypeScript doesn't like that very much, right? The typings on getting autocasting to work are difficult. So when you're doing TypeScript, I still recommend that you new up like a renderer. New up a graphic, new up a, you don't have to necessarily new up a symbol, but maybe new up the colors. You'll run some weird TypeScript things if you don't, and you start having to cast things as any. So just ignore the auto casting with TypeScript. It can be useful in some places, but being very explicit is also very clear when you look at your code as to what it is you're trying to do. You're trying to create a new unique value renderer. I don't have to look at the object and go, what is the type of that object? Okay, it's unique, but no. Just create a unique value renderer and everything's going to be working just fine. Because it's supported in constructor signature only, this is the part here where we've kind of got some typing issues there. But in TypeScript, new it up, everything works great. Like I said, it's fine if you're doing regular JavaScript, but TypeScript, maybe not. Generics. So you can use generics in a lot of places. So how many people here use the collection in the API, like on its own without like, okay, so the collection is really cool. So you can have a generic on the collection and tell it to be like a collection of graphics, right? And it just means that it's going, everything you add to that collection has to be a graphic. That doesn't mean it's going to cast anything to a graphic for you. We actually have, I don't think I have a sample with it, but there's a static method of collection called ofType. And if you give it a class of some sort, like graphic or a web map or something, it will convert any objects you pass to it to be a graphic or a web map. It's actually going to new it up for you. Using the generic isn't going to do that. So don't think that you can just pass an object and things are going to work. You still have to pass the actual a class instance of whatever it is you want in there. And TypeScript will complain too. If you pass an object there that isn't a class instance, then it should complain and tell you, no, you've told me that I should expect graphics, so please give me a graphic. Right, so that's really a cool feature. All of the events on the map view and stuff, we have strictly typed events in the API. So like on mouse wheel and on pointer move and stuff, those are strictly typed, which comes in really handy when you're doing interactive apps. And we already kind of talked about how the advanced autocast, like colors, red, screen sizes, and base map stuff, those work. They should still work just fine with TypeScript. Not much of an issue there. We had some issues early on with that, but we've kind of fixed them. So like you create base map streets and you'll be okay. It's not a big deal. But let me look at some stuff here. So promises, right? Promises are big in the API. And I've talked about this a few times. We use them quite a bit. Our API, since 4.7, the promises have been more compatible with native promises. So if you do like query features, you can do like promise.all around a bunch of query feature calls and everything works great. You don't worry about this stuff with Esri core promise. We have a promise module in our API that kind of mimics the native promises, but under the hood, everything is still these deferreds and everything, and that is because you can't cancel a promise. They promised it, you can cancel a promise at one point, then they say, no, you've taken away cancel from promise. No, don't do that. There's another way to do that, but we have it on our request methods, so you can pass this abort signal to our Esri request, and then you can tell the signal to abort at some point, and we're trying to work out how we can do something similar for our promises and stuff. So our general advice is to wrap API promises in native if you need it. So if there's something in the API that is not returning a promise as you expect it to, wrap in a regular promise. But I don't think this is true anymore. I mean, I put this in here, but I was thinking about it last week, and I think pretty much all of our promises from every public method we have should act like a native promise. So if we look at some of the, and I won't do the Vim bit, let's go, where my VS Code go? Here we go. So if we look at like async await, right? So do I have a slide in async await? I think I do. So let me show you the slide first before I start jumping into things. No. All right. So async await is kind of a new way of dealing with asynchronicity in JavaScript, right? It's really fun. So here what I have is a function, a module that's going to query an elevation layer, and I'm using the async version of our geometry engine, right? Here is how you would normally do it. I have this function, and this is all still TypeScript. I'm going to densify a line, then I'm going to query my elevation layer, return the result for that query. Then I take my result, and I'm going to get the line with the z value as a polyline. And then I'm just going to iterate over those lines and pass them back. I'm going to exaggerate the z values and pass that result back, right? So this is a big old promise chain. I kind of like these because every then block is scoped. So I can have some different variable names. I can do some other cool stuff in here. It's kind of neat. And I'm still kind of a fan of doing promise chaining. But you can use async await. And you get this just out of the box with TypeScript. So every time you use async await, it has to start with async keyword with your function. And then what I'm going to do is that if you have an async function, you're now allowed to use the await keyword. So my densified line is going to be equal to the await result of the densify async function. And then I have my query elevation layer method where I'm going to go ahead and await the result of that. And I'm going to see here I just grab the geometry right off of that result. I'm not going to wait till the next line to do it. And then I iterate over it and I go ahead and exaggerate my z values. This is cool because everything kind of looks synchronous now. I can kind of read it as a very simple step 1, step 2, step 3 kind of thing instead of addendable promises. The one thing to remember is that these are blocking, right? So the one line after an await call won't run if the previous line errored out for some reason, right? So what you would do is that when you call this method, and I'll do it down here, you wrap everything in a try catch. So I'm going to call my, what was this function called? Make elevation profile method. You call that in a try catch, and then over here is when you're going to catch your error and you do something, hopefully you do something useful with your error, right? And this is equivalent to the dot catch on a promise chain like this, right? So that's how you kind of handle errors with async await. I mean, it's kind of funny. I mean, I had not used try catch in a long time before async await came around. It's kind of a thing you used to do way back when. Yeah, I mean, it's valid. It completely works. So this is kind of how you deal with asynchronicity there. I did want to show, this was a cool feature on the point styles. I think this is the right one. So this is the old way that used to bring it in. And I had to sample it because I meant to show this to you earlier of how you used to bring in our layers and stuff like that. But you don't need to do that anymore. You just kind of do it as is. So you can see here that in this case, like when I create a web scene, this object is valid. I don't have to do as any here. So this is a case where I don't have to actually instantiate a new portal item in my constructor here. It just kind of works. That's really nice. And let's try to think what else was useful in this one here. I cannot remember anymore. I wrote this sample quite a while ago. But okay, so I know what's coming up in the next slide, so let me show you that. So writing accessor-based classes. So okay, so this one When you write classes with our API and you're going to extend classes, we've talked about Accessor before. If you're not familiar with it, I suggest you, there might be a couple sessions on some intro stuff that you might be able to check out. But we provide decorators for the Accessor classes to help you extend them a little easier. And these are decorators for doing subclassing and everything. And let me see here. So I have a subclassing example here. So the reason for this is that JavaScript classes do not provide a way to do multiple inheritance, right? You can extend only a single class. You can't extend multiple classes, which just does not work for us in the JavaScript API. We got a lot of different classes we need to extend together. We may throw an event into something. We may have some kind of query subclass that we use and stuff. So we throw all that in there pretty nicely. So we have this helper decorator to extend multiple classes called declared. And here I'm going to go ahead and I have base1 extends declared and my accessor. And I have a subclass decorator that goes with the declared decorator. Now under the hood, we're still using Dojo's declare method to do multiple class inheritance because it really is the only JavaScript utility that does multiple class inheritance nicely. There are some things in TypeScript that we want to do to see if we can make it work with mixins. If you've used mixins in other languages, you can kind of mix classes together, kind of via the name. We think it'll work. We just, we need some testing and stuff to make sure it's going to do what we need it to do. So I've got two classes here. One's got a prop1, one's got a prop2. And then I don't need this anymore. I can literally remove that now. And now I'm going to go ahead and I have a class here that's going to extend both base1 and base2. And when I do that, I'm going to have instances for prop1 and prop2. Oh, it looks like I did need that. I shouldn't have deleted that. See what happens when you do things on the fly around here? So now my instance, my new class has prop1 and prop2. So it was able to inherit properties from both of those classes pretty nicely. So I think the same thing for this exaggeration elevation layer. So now, if you haven't seen some of the samples we have in the API, you can extend custom layer views and stuff like that. In this case here, I'm extending the elevation layer. So to have it do some stuff of my own, so I'm going to exaggerate all of the elevations in my layer, and you get a really funky looking layer, which is kind of nice, right? So it's kind of a fun way you can do that, but I won't go into details in the code because the main thing is the fact that I am just extending my elevation layer using that declared helper and then the subclass decorator to kind of bring that in, right? So that's kind of cool. You'll notice these things at the top here. We have these helpers at the top using this AMD dependency bit. This is so that when the TypeScript compiles, it will just reference a single helper file and it won't inject the helper code into every single file where it needs it. It kind of just saves on file size among all our files, right? It's a cool way to do some stuff with your applications. One of these days I'm going to figure out which direction I go to get to my slides. There we go. So we talked about multiple inheritance, declaration merging, and everything, and making sure that everything is supported in TypeScript. At runtime is strictly checked. That's when you do the multiple class inheritance, that was a tricky part for us to begin with to get all the typings to work correctly. But if you use our declared helper along with the subclass helper, then you'll get all this nice type checking and stuff along the route. All right, so our typings are really cool. We put everything in our typings, but they may not be perfect. And I'll be the first to admit that. It's not my fault. But if you need to patch our typings for any reason, you can, right? So let me show you, wrong way again. I'm going to learn someday how you can do that. So we have this type extensions here. Essentially what you want to do is set tsconfig and point it maybe to a typings folder. It's convention, it's not a rule, just I have everything in a typings folder. And in my typings folder, I'm going to say I've got some extensions for my typings, right? So we have a namespace underscore Esri. So I declare that namespace. And then I'm going to go ahead and override the ground type. So I create an interface for my ground that because I've added this new elevation layer result that's missing from my API, I can add that to the ground type to be able to do query elevation correctly. All right, so this is kind of how you can patch our typings if something isn't quite right, or if maybe our doc was wrong, because our typings are generated from our doc. So if you see that, you can always do that. And if that comes across that, you can make an issue on JS API resources on GitHub. We all check it out and we'll get the issue. We can't fix it in the typings. We have to actually fix our doc, and then it gets fixed in the next release. And it also helps us catch some stuff. So if you see that, please let us know. Wrong way again. Okay, so not questions yet. No, I'm gonna head over to Stefan, and he's gonna do a really cool demo for you on TypeScript.
Right. So what we'll do now is basically take an existing sample which we published in JavaScript and convert that to TypeScript, and you should see some of the things René mentioned already happening here, what happens to autocast and other problems. And this is a typical thing which we do sometimes, less and less now, because more than 90% of our API is already TypeScript. We still have like some tests and stuff, and every time you run across a test and need to update it for some reason, we'll take the test and TypeScriptify it. So it's the second time I'm doing it. I did it once before just to see that I can do it in time, and let's cross fingers that it works again. So that's the example we have. It's a little 3D application for point styles for cities. So it has some renders, some symbols, some layers, your typical 3D application. So let's grab the code. And the internet is slow. All right. For some reason, I already have a backup plan here. Let's grab the code from here. You have to believe me, it's the same code. Copy that into my example and just save that file. And now let's check that the example still works. Here it is. Okay, let me grab it here so you really believe me that I took the right code and not something prepared. And that's the application we're going to work on. So I reload that one, and it's still loading up and doing everything correctly. Great. So now, what do we need to do to TypeScriptify it? So first, in the sample, everything is in the index HTML. So what I'll do is just grab the JavaScript code and cut it out here and put it into a TypeScript file. So that's all my JavaScript code until here. Let me get that out. And I have prepared a little application.ts. And, well, of course, that won't directly compile, contrary to what René said earlier. But we now also need some boilerplate code here with JavaScript to actually load the TypeScript compiled JavaScript file eventually once we have it fixed. And I prepared that a little bit. That's part of the documentation René mentioned, so nothing fancy here. I just copy that over. And we have too many script blocks. Let's get rid of that one. And I also need to remove the loading of the API on top. And that should be the part we need to do in the index file. Now let's go back to our application. First thing I'm going to do here is to fix up this require statement to actually use imports. I also prepared these because I'm going to need a few more, because I'll import more typings than we had in JavaScript. That's already nicely prepared here. And we are going to now create a class which will take up our code. And because I'm lazy and want to get done in the next 15 minutes, I'll just do all the work in the constructor. And then we'll have to close the braces at the end correctly again. Yep, let's not worry about formatting too much, because TS-Lint will fix that for us. And now let's check what's the next thing we'll have to do. Yes, so next thing I'll do is just to run TS-Lint on that stuff to fix up mostly some minor things. So one great feature of TS-Lint is that it has, for some of the rules, an autofixer. So one thing you do in TypeScript is you use const and let instead of var keywords to declare your variables. So I'll just run tslint a couple of times here. You see it has a few things that which it will fix. One little bit annoying thing with it is some things are cumulative, so you have to run it multiple times until it actually fixes everything. But you see we still have a few things left here. So now if we look at that file, what we actually see here, that there are some problems here because we are in TypeScript, we actually want typings. So since I did that before, I know that my name is a string, and my color is a string too. And because I'm lazy and I also wanted to show that, the return value, I'll just do an any here because we actually return some type of object. So that's that part. That already looks way better, but that will still not compile yet. And the next thing which we have to do is to fix the remaining errors. So if we go down here, we see that this constructor of a feature layer has a few things where it complains about stuff which doesn't work. So for example, the points renderer is you're confusing me now. It's actually not of the right shape. So what I'll do now is that I just comment out all that stuff and then fix it one by one until that stuff is green. So the first thing is the points renderer. And let me comment that back in. What I'll see here, that's just an untyped object. I'll prepare that one as well. What I do instead is that I new it with a unique value renderer because I know it's a unique value renderer, and that's about the only thing I changed. I'm a little bit sneaky. One thing I'm changing here as well is that in the sample we had a relative URL for all the icons. I just changed that to an absolute one, which is why I'm copy-pasting all that code, such that they can be loaded properly and I don't have to download them to my local machine. So I have the points renderer now, and now this guy is green. Now let's comment in one line by one line. Outfield star, that works nice. This is just a comment line anyway. Then feature reduction, I believe, works nicely as well. And the last thing which is problematic is this labeling info. So if I comment that in, the first thing we see here is that label expression complaints. And one interesting thing is that we changed the API for the label expression info is that value is deprecated and you should actually use expression info. So that you couldn't see in JavaScript because it doesn't warn you of that type of thing. But what we should do instead now to be more future-proof is to use that. And as soon as I put that stuff in here, TypeScript is happy. And then the last thing which is missing here, it's autocasting not quite working correctly. You actually want to new that stuff. Luckily, the sample writer did a good job and already wrote what I need to do here. So I just do a new label symbol 3D, close the brace correctly. I don't need that one anymore because that's automatic. And same for that text symbol layer. Let me grab that. Yep. And close, and I can remove the type. And now this guy is happy, and now the only thing which is left here is this event handler, where we just have to type the target more narrowly. I know that this is an HTML input element, the target, so I'll just cast that out of the event. And then use this cast target everywhere where it's complaining that it doesn't know that it has checked. And that's actually a nice thing that you see here is that you get way more narrow typings and you see where things are not there or should be there, and then you can do your due diligence if it's actually the correct thing to do. I'll get back to that render in a bit. Let me finish the event target. I think that's it. Now there's one more. I missed a function here which doesn't have a return value, so let me just convert that into an arrow function, so you see that one as well. I think there's a second function somewhere if I remember that correctly. Well, we'll see that later. Here we see that the renderer.clone isn't known, and the reason for that is that the points layer renderer is just a renderer, but I know from creating the unique value renderer early on that our renderer is actually a unique value renderer. So let me just cast that to the correct type, and then it should work again. Here we go, that looks good. And the same for that symbol. The symbol was point symbol 3D, I believe. Yes, point symbol 3D, where the autocasting worked, funnily enough. So let me cast that one as well. And I missed one of the event targets. And now we are all green here. So let's see if we can actually compile that. npm run watch. Now the TypeScript compiler does its magic, and wow, we did it on the first go. So let's reload our application here. And the icons don't show up. Oh, I think because I have actually caching on. Let me do a hard reload. No, the icons don't work. That's interesting. It still tries to load the local icons. I'm not quite sure why that is. Oh, yeah. Let me go back to my TypeScript file, but we see that it already loads the, because I didn't save the index HTML, it's still the old one. Right. So now we should actually get the new one. Yes, because I forgot one thing, so we get an error, it doesn't load for some reason. And the reason is that I did all my class, but I did not actually export it, so we can access it from our index HTML. Where my keyboard has the wrong printing on it. Right, so now once we do this, that should be the last one. We have it recompiled here, yes. Reload again, and it works. Right, and we even get the icons now. So as you see, we did that in about 15 minutes for more than 100 lines of JavaScript code. Of course, there are still quite a few things which you would want to improve. You would want to get rid of the any, which I had up here. Where is it here? That's actually a point symbol 3D. So if I do that now, that won't work. Because we would want to new that one. Oh, what did I do here? New point symbol 3D. We have a bit of time, right? Cool. And let's see if that works. Right, but then we also have to do the right thing for the icon symbol layer. It's kind of always the same thing you tend to do, so it becomes a bit mechanical eventually. We can get rid of that one. I did something wrong here because it's the wrong brace. And we are missing the icon symbol layer, 3D and the import, so let's move that one up. So we are green again, and we have better typings on that one. So that's typically how you work with that stuff. Then there are a few other things which you want to refactor, of course, in a real application from an architectural point of view. You don't want to do all the magic in the constructor, but you want to break it out into more classes and drive that correctly. Let us see, so that compiled nicely here, and I'm just going to reload to check that it still works. And I'm pretty sure it does still work. Voila. And with that, I think we can go back to questions.
Yeah, awesome. That's cool. I dig that. All right, so this time, yeah, we can take any questions anyone's got.
There was one like that.
Do you just talk about that export statement and when it's necessary in TypeScript, when it wasn't necessary in the JavaScript group?
So the question was if we could kind of talk about the export statement and why you need it in TypeScript. We didn't really use it before in ES5 JavaScript. New JavaScript, modern JavaScript and TypeScript, when you're working with modules, you would always export a module. The way like Stefan did it here, we did the export equals is how you would do it so that it would work with nicely if you're going to load that module in an AMD environment. But typically you would just export a module and then you can use those brackets to kind of export just the pieces of module that you want. And if you do an export default, that'll just be the name without the brackets, and it'll bring in that module all by itself. The rules typically apply. You should only have one class per extension, and usually the default is going to be the class, and then any helpers or interfaces and types would be exported separately. That's kind of the rule there. But like in our case here, we did the export equals because we were loading in AMD, and it would just make it easier to do it that way. Any other questions? Yes?
Are you going to write the ArcGIS API in TypeScript?
No, because it is already in TypeScript.
Yeah. So the question is the API already in TypeScript? ArcGIS API 4 is already in TypeScript. It is, I think the last number was 90% TypeScript at this point. We still have some JavaScript that we need to convert over, and every release we do a little bit more. Every release we add a lot more code too, so the number kind of, it's 90% now, but like if we hadn't added any code a few years ago, or I'm sorry, this past like year or two, it probably would be like 98% if we didn't add more code, but yeah.
And a large part of that is actually in tests. So I would say the API itself is probably above 95%. I haven't run the numbers, but.
I mean, like when you look at your, when you look at your tests and you're like, oh, that's a lot of JavaScript, I need to convert to TypeScript. Like, I can wait, right? So, any other questions? Everybody's going to run out here and install VS Code, do TypeScript. Yes?
So in your example, you had various types of import statements. Your code is sort of rewritten. How do you determine which one to use? I mean, you've got basically the first import statement, I guess, assumes that it's not the default value of the
Oh, yeah.
You also then go down and import web scheme equals require. So when do you use different types?
So I think like the ones. So like the ones here, so if you turn on tsconfig ES module interop and you say it's true, then you do not need those require calls. This is just kind of a quick way to do it for this demo purposes. But if you turn on the ES module interop in tsconfig and you're using TypeScript 2.72 and above, I think it is, then you can just do regular imports without the require. The brackets, we actually in the API what we did is we have these like modules. There's like a renderers.js that exports out all the different renderers that are available, and that's why you can use the brackets to do that. And the same works for geometry, so you can do import bracket point from Esri geometry. It's equivalent to doing import point from Esri geometry / point. Yeah, so today you don't need the require calls. Right there. That's, yeah. If that helps answer it at all. Yeah, so that one's for geometry, works perfectly like that.
It's just a warning because I'm not using point here.
Yeah, exactly. And that's, again, TypeScript's cool. It'll warn you if you're not using something with your TS-lint and everything. Yes? So, I'm sorry, repeat the question one more time. Oh, yeah.
It's just my workflow because I like to see, I have on my desktop a little console on the side to see the errors there as well. You can also run it from TS.
Yeah, so the question was, in our sample here we use command prompt instead of VS Code to do the build and everything. That's preferencing. VS Code also has the ability to add build scripts, so you can tell VS Code that in your project you push a little play button and it'll run the watcher and everything for you, and you can even do debugging inside of Visual Studio Code, which is a nice feature. I don't use it either. I run everything in a separate command prompt usually, or the terminal that's part of VS Code. So it's just a preferencing. Any more questions? Anything at all?
There's one more.
Oh.
Have you done debugging for this stuff?
Yes. Debugging works great outside of our Webpack build stuff. But debugging will work great using TypeScript because you'll get source maps to the source TypeScript files. Issues with Webpack are something that are kind of beyond something we can fix right now. It's weird. It'll tell you line 26 on application.ts, but you click that link and it's actually the compiled JavaScript, which is odd. I think that's part of just the way some dependencies that we use in Webpack to do things work. Because I know someone's gonna come up here and tell me that that's not the case with Webpack, that's why I mentioned it. But if you're not using Webpack, you're just doing like what Stefan did now, yeah, you definitely have access to the TypeScript source in Chrome DevTools or Firefox tools to do it. Yes.
Yeah, I've had it working from Grunt to go back.
Yes.
TypeScript, but I was more wondering the VS Code's inbuilt debugging.
Oh,
Yeah, that works well as well. I'm not quite sure how to set that up, but I know a colleague actually is using it as well.
yeah, me too. I don't know how to set it up, but I know someone that uses it too. When it comes to those like build tools in part of VS Code, I'm so command prompt use. I don't bother, but they're there. It's power. Like I said, it's powerful. You can do a lot. Yes.
Are you guys gonna? So autocasting doesn't work right now. Is there anything you guys might be future to make it work? Or?
Partially works.
Yeah.
It's really hard to say.
Yeah, it's hard to say. We've got to. I think we need to make a little bit push a couple more issues on the TypeScript team for some things to help us support that.
So here, for example, you have one where it actually works. Typically what I'll do when I convert an existing one, I just fix the ones which don't work and I don't bother too much about it. Because once you have done it, you're actually not bothered by having a new something there instead of autocasting it.
Yeah, like I said, when you look at having the new things up where needed, I mean, it's very explicit and it's kind of nice. I've kind of gone back to doing that today. Any more questions? All right, cool. Awesome. Thanks, folks. Appreciate it.